Here's a quick video with some computer observations about curvature. So we have to figure out how can we tell if something is curvy or not. And I'm going to do this at first with a parabola. And so I'll have this point here, which is moving along the parabola. And it turns out this is not the tangent vector, it's the unit tangent vector. So I took the tangent vector and I normalized it. I divided by its length. And that is handy because I don't actually care about the length here. I just want to know the direction that something is moving in. So as this moves along the parabola, you'll notice that it doesn't change length at all. So it shows us the direction of instantaneous motion, but it never changes length, even if the particle is moving up or slowing down a little bit. Next thing to pay attention to is down here where there's another vector. It turns out that's actually the same vector. It's the unit tangent vector. I've just copied it and pinned it right here. So I draw all of them starting at the center of this little gray circle, the inset down here. And so you should stare at this as the point moves through the parabola once or twice and convince yourself that that's really the same vector pointing in the same direction, just copied down onto that disk. Now pay attention to what happens to that unit tangent vector as we move along. So the sides of a parabola are pretty flat, and when the particle is on the sides, the tangent vector doesn't change much. You can see that by looking over here. See, it's pretty much the same. Or on the left side, it more or less points to the lower right. It's only when the particle gets to the middle of the parabola, near the vertex, the curvy part, that the unit tangent vector actually changes a whole bunch. And that's what we're going to try and detect. So one more time, more or less the same, quickly changes, and now more or less the same. Just to drive this point home with a few other examples, instead of the cubic, let's see this with the quartic, which is really flat at the bottom but has two curvy spots on either side of that vertex. On the sides it's really flat, so more or less the same, changes, same, changes, and same. I'll let that run one more time. And finally, just to show you something that's not a parabola, let's look at the sine wave. So the sine curve is curviest at the top and the bottom, and in between it's pretty flat. And you can see that as you watch the unit tangent vector in the disk here. In between, it stays more or less pointing to the southeast, down and to the right, and it changes pretty quickly when we're on the top and the bottom. All right, now you can go back to the other video and figure out how do we quantify this in a formula.